In these notes, this is a continuation of the last lesson that we talked about with the remainder theorem. So what you can do is get your heading on your paper. We're going to take it a step further and talk about using the remainder theorem to determine if an expression that we're dividing by is a factor or not. So this is the review from what we talked about in the last chapter, if you could write, or the last notes, if you could write that down. When we are taking a polynomial and dividing it by a factor, we would get a quotient if we would use long division, and then we would get a remainder, and the remainder, quotient remainder theorem, or quotient remainder form would look like this. You'd have your quotient, and then you would add on your remainder over what you divided by. So I just want to point out what these all are again before we continue. So this on the top would be the polynomial that we start with. So if you can write polynomial. This is the factor that we're dividing by. And when we divide, we would get our quotient. That's from the long division. So this is our quotient. And then at the top, we would get our remainder. And we've seen it before as R, or now we're going to write it P of A. And we learned that if we ever want to find the remainder, we can plug in the opposite of what we are dividing by, what number is in the factor. So what I want to do is take it a step further, and I want you to notice something about when we get a remainder of 0. So here's our first example. Can you write example A? And can you write using, and we're going to have a fraction here. On the top of it, we're going to put 3x squared minus 7x minus 20. And underneath it, we're going to put x minus 4. We're going to do 3 things for this problem. So we're going to have 1, 2, and 3 in here. So the first thing we're going to do is we're going to write simplify using polynomial long division. So simplify using polynomial long division. That's our first thing that we're going to do. So again, review just because I want to make sure we know how to do long division. Here is my division symbol. What I'm dividing by goes in the front, so x minus 4. What I'm dividing into goes underneath the division sign, so 3x squared minus 7x minus 20. So we're going to divide this. So we say to ourselves, what times x gives us 3x squared? That would be 3x, so we put a 3x at the top. We're going to multiply this x minus 4 by 3x. So x times 3x is 3x squared. That's what we wanted because we want these to match. 3x times negative 4 is negative 12x, so that goes underneath the negative 7x. We're going to combine, but remember we're subtracting, so we're changing the signs of what we just wrote. Now if we combine straight down, our 3x squares cancel out, which is what we wanted. Negative 7x plus 12x is 5x, so I'm going to bring down the 5x. And now I bring down the next term. Since I'm dividing by 2, I need 2. So I bring down the minus 20. Now we compare the first terms again. X times what gives us 5x? That would be a positive 5. So I'm going to put a positive 5 up here. We are going to multiply both of these terms by 5. So x times 5 is 5x. That goes underneath. 5 times negative 4 is negative 20. Now I'm going to combine by changing the signs of what I just wrote. So that becomes a minus. This becomes a plus. My 5x's cancel and my 20's cancel. So I'm left with 0. Part 2 on this, I want to answer this question. So this was what our answer simplified to, by the way. So I will circle that because we had no remainder. Number 2, can you write what is the remainder? What is the remainder? Well, that answer is right here. So the answer is 0. One more, number 3. Evaluate P of 4. Where did I get this from? Well, P is our polynomial, so we're going to plug this into our polynomial that is right up here, and we're going to change every P to 4. Where did the 4 come from? Because we are dividing by the factor x minus 4, and we're going to plug in 4 instead. So I'm going to have P of 4 equals, instead of 3 times x squared, it's going to be 3 times 4 squared. Instead of minus 7 times x, it's minus 7 times 4, and then plus 20. Oops, minus 20. So let's get rid of that plus. So again, there's two ways I can do it. I can type into my regular screen what I have right here. So I'm going to type in 3 times 4 squared minus 7 times 4 minus 20. And I get 0. I can always go to y equals and type in my original and look for 4 as well. So what I want you to notice is, because we got a remainder of 0, this x minus 4 is a factor. If we got something else besides a 0, it wouldn't be a factor. How can we figure out if it's a factor? By doing long division or plugging it in to see if we get 0. So I want to summarize that in a little sentence, and then we're going to do some examples to practice. So here is our summary. And I'm going to put notice in big capital letters. This is the important part. If x minus a, I'm going to put that in parentheses, is a factor of p of x. So that means if we can take a polynomial and divide it, then there is no remainder. And if there's no remainder, that means the remainder is 0. So I'm going to put p of a equals 0. That means when you plug it in, you will get a 0. It also means that if I was to graph this function, if I was to graph the polynomial, it would touch the x-axis at that number. So for instance, if I was to graph this, since there was a remainder of 0, it would touch the x-axis at positive 4, because remember, our 0 is the opposite of our factor. And we'll get into graphing later. So we're going to do some examples here. So this is example B. And I'm just going to ask you, this will be B1. Is x minus 3 a factor of p of x equals x squared minus 11x plus 24? So we're going to figure this out and put yes or no. So we can do long division and divide to see if we get a remainder of 0, or what we can do is plug in the opposite of the number inside the factor. So to see if it's a factor, the opposite of negative 3 is positive 3. So we're going to do p of 3. My work is I'm going to show all of these x's changing to 3's. So we're going to have 3 squared minus 11 times 3 plus 24. So I can go to my calculator and type that in, or you can go to y equals. So I'll show you both one more time. So 3 squared minus 11 times 3 plus 24. We get an answer of 0, so the answer is yes. So you want to make sure that you show the remainder and you show it's yes because there was no remainder, it was 0. The other way that you can always do this is you go to y equals and type in the original, so x squared minus 11x plus 24. You want your table to start at 3 or somewhere around there, and you look and you get a 0. So I typed in the original, went to my table and looked for 3. Here's another example. You can pause the video if you'd like. Is x plus 5 a factor of p of x equals 2x squared plus 9x minus 2? How can we do this without long division? The remainder theorem says that we can plug in the opposite of the number inside the factor to see if we get a remainder of 0. So we're going to do p of negative 5. I'm going to change all my x's to negative 5. So 2 times negative 5 squared plus 9 times negative 5 minus 2. There's the work we would show. I can go to my calculator and go to y equals and type this in, plus 9x minus 2, or you can type in all of that. I'm going to go to my table and look for negative 5. So I'm going to have my table start at negative 5. And notice I get an answer of 3. So is it a factor? No. It only is a factor if you get 0. Here's the next one. We've got 3 more to do. Same kind of question. Is x plus 1 a factor of? Is x plus 1 a factor of p of x equals x cubed minus 7x squared minus 11x minus 3? And feel free to pause the video, do it on your own, and check your work. So if x plus 1 is a factor, I can plug in -1 and get 0. So let's see what we do. So I'm going to do p of -1. I do the opposite of the factor. All my x's become -1 now. So this becomes -1 cubed minus 7 times -1 squared minus 11 times -1 minus 3. So this time I'll do it by plugging in the number. So I'm going to do -1 to the third minus 7 times -1 squared minus 11 times -1. Make sure I'm doing this right. Minus 3. I get an answer of 0. So the question says, is it a factor? Yes, it is, because we have a remainder of 0. That means it would touch the x-axis if I was graphing it at -1. 2 more. Example 4. Feel free to pause the video. Is x minus 5 a factor of p of x equals x cubed minus x squared minus 19x minus 10. So in order to determine if it's a factor, we're going to use the remainder theorem. We're going to plug in p of 5, opposite of -5. So we're going to plug in p of 5. So every x becomes a 5. So this becomes 5 cubed minus 5 squared minus 19 times 5 minus 10. I'll go to y equals and do it like that this time. Go to y equals, type in the original. X cubed minus x squared. And I'm going to look for 5. So I have my table start at 5. And I get -5. So is this a factor? No, because we have a remainder. And last one. This is number 5. Giving you the wording just because I've seen this on the regions before. Consider the cubic polynomial. Consider the cubic polynomial p of x equals x cubed minus 3x squared minus 40x plus 84. And then the second and last sentence is x minus 2, I'm putting that in parentheses, is x minus 2 a factor of p of x? Well, this is the same question, but just worded a little differently. So to figure out if x minus 2 is a factor, we are going to plug in +2. So we're going to do p of 2. So every x becomes a 2. So we're going to have 2 cubed minus 3 times 2 squared minus 40 times 2 plus 84. So I can type that in or go to my y equals. Last part, x to the third minus 3x squared. So I typed in the original. I want my table to start at 2. So second window, having my table start at 2. Go to my table. I get 0. So is this a factor? The answer is yes. So when we do our classwork this week, your classwork will be just like this. Please make sure you submit these notes into Canvas to get credit.